Alright, so here at number 1 we start going back through chapter 6. So if you're looking through your notes, this is where you would want to look at for information on the following 13 or 14 problems. So you, on number 1 here, want to just plug in a 2 everywhere that x is. So on top that's 2 minus 10. On bottom that's 13 times 2 minus 6. If you do this in the calculator, you want to put parentheses on top, parentheses on bottom, and divide in between. But by hand, that's negative 8 over 26 minus 6, which is 20. And then simplify that. You can divide the top and the bottom by 4. So that gives you negative 2 over 5. And that's your answer. Number 2, find the domain. Set the bottom equal to 0 and solve for x. And this should seem familiar to us from our work with vertical asymptotes recently. But for domain, our answer is going to be all real numbers except x does not equal 6. Okay? That's the domain. X can't be 6. It can be anything else. Now, this chapter had a lot of factoring. Anytime we're trying to simplify, whether we're adding or multiplying or dividing, we want to factor. So this has 3 terms, which means we can split it into 2 parentheses where we're saying what multiplies to get 36, that adds to get 13. So that's 4 and 9. And then on bottom, same kind of thing. What multiplies to get 63, that adds to get 16. And we would pick 7 and 9. And so the only way you can cancel out, notice I didn't just cancel out the y squareds back here, because you can't do that. Like, that doesn't work. You have to factor to be able to simplify. And so once you have it factored, now if things are exactly the same, they cancel out, like the y plus 9s. And they leave you with y plus 4 over y plus 7. And then you cannot simplify any further. You can't cancel out those y's and say it's 4/7, because it's not. That's not the way that works. That plus sign protects you from being able to cancel those out. On number 4, we're trying to multiply, but before we multiply, I personally like to factor. You can multiply and then factor, but I don't know, I like to factor first. So can't do anything with the 2y, but on bottom we can take a 2 out, and that leaves us with 2y plus 1. Remember, if there's 2 terms, you're looking for what they have in common, like what number they can both be divided by. And on the top of the second fraction, we can take out a 7 and be left with 2y plus 1. On bottom, we still have that 4. And so if you look, we can cancel out the 2y plus 1s, and we can cancel out these 2's, leaving us with a 7 and a y on top that get multiplied together, and only a 4 on the bottom. So our answer is 7y over 4. When we divide rational expressions like this, these fractions, remember you take the second fraction and you flip it. So we're also going to factor here so we can simplify. On top here, we say what multiplies to get 15, that adds to get 8, which is 5 and 3. On bottom, we say what do we multiply together to get 18? That will add together to get 9, which is going to be 6 and 3. Now, I'm going to flip the fraction and factor at the same time. So x squared plus 11x plus 30 is going to go on top. So that'll factor into 2 parentheses. What multiplies to get 30, that adds to get 11, which would be 5 and 6. And on bottom, x squared plus 5x, what do those have in common? Since there are only 2 terms there, we have to say, what do they have in common? Which they have an x in common, leaving us with x plus 5. And now we go crazy with canceling, because tons of stuff cancels out, like x plus 3 over x plus 3, x plus 6 over x plus 6. And then one of the x plus 5s on top will cancel with the one on bottom, and it doesn't matter which one you cancel out, just make sure you don't cancel them both out. So that leaves us with x plus 5 over x as our answer. You cannot cancel out an x here because the top says x plus 5, not just x. Number 6, we want to add, simplify the result if possible. So they both have a common denominator of x minus 6, so you might be inclined, because we've been factoring so much in the last few problems, to try to factor the top up here. But we want to add first and then try to factor. So if I add my numerators together, nothing actually combines. I just now have a trinomial instead of a binomial over x minus 6. And then I would factor the top to see if it'll simplify, which I'm looking for what multiplies to get 12, that adds to get negative 8. And on bottom we've got x minus 6, so that cancels, and I'm left with x minus 2. Alright, subtract. We've got common denominators, so, and the problem before this, I don't remember if I said it, we had common denominators, that's why we started straight off with adding. So here we've got common denominators, so we can subtract the numerators and we get 4 over 5x squared. You would check and see, hey, can I simplify that? And the answer is no, you cannot, so that's our answer. On number 8, we want to find the least common denominator, and so on the bottom here, we need to factor, so they have an x in common, which leaves us with x plus 3. Here we want to factor, which goes to 2 parentheses. So what times what gives, so what multiplies to get 3, that adds to get 4. So you'd put plus 3 plus 1. And then the way we find the common denominators, we're basically making a list of all of the factors. So we need an x, we need an x plus 3, we need an x plus 1. Okay, so that's the list of things that we need so that the denominators will be the same. Notice we didn't write x plus 3 twice, we just had to write it once. So now, on number 9, let's find a common denominator so that we can add. So I have x and x minus 4, which means my common denominator is going to be those two things multiplied together. So the first fraction right now has an x, but it needs an x minus 4. So if I multiply the bottom by x minus 4, I have to multiply the top by x minus 4. That's the rules. The second fraction has an x minus 4, but it needs an x. So I need to multiply the top and the bottom by x. So here on top, I will distribute the 3 and get 3x minus 12. And then the other one, we just have 5x, so that gets added together. Add like terms, so 3x plus 5x is 8x minus 12 over x times x minus 4. And then you really should check this out and see if it factors so that we can see if it simplifies. You can take out a 4, and that gives you 2x minus 3. But that does not cancel anything out, so this is our best answer. Simplify the complex fraction. So we want to make it to where there's one fraction on top over one fraction on bottom. So on top, I have a denominator that's 1, a denominator that's x, so my common denominator is going to be 1x, which is just x. I need to multiply the first fraction by x in order to get that common denominator, which means that on my numerator I'm going to have 4x plus 2. On the bottom here, I've got a 4 and an 8, so my common denominator is 8, because I can take the 4 and multiply it by 2, so that it turns into our common denominator. So that gives me 2x plus 1. Now, these are fractions being divided, so we write down the first one, and then we flip the second one, and then multiply. Before we actually do that, let's check and see if anything factors, so we can try to cancel something out. 4x plus 2, you can factor a 2 out of, and that leaves you with 2x plus 1. So that's actually helpful because I've got a 2x plus 1 on the bottom here, so that the 2x plus 1's cancel, leaving you with 2 times 8 on top, which is 16, and just x on bottom. So that's 16 over x. 11, to divide here, I like to look at it like this, like we're taking everything on top and dividing it by the thing that's on bottom. So 35 divided by 5 is 7. X to the 7th over x to the 6th simplifies. All of the x's cancel out but 1, and it would be up here on the top of our fraction where the 7 would be as well, because there's more x's on top. 25 divided by 5 is 5. X to the 6th over x to the 6th, that just cancels out completely. 30 divided by 5 is 6. X to the 5th over x to the 6th makes there be an x on bottom this time, because they cancel out except for a single x is left. These are a single number apart, but where are there more? There are more on bottom, so that's where we put it. So that's our answer to that. Use long division to divide. So this is how we do it. So we're going to say, what do I multiply 3x by to get 15x cubed? The answer to that is 5x squared. Then you go back and you multiply both of these by 5x squared and you subtract. So 3x times 5x squared is 15x cubed and you subtract. 5x squared times 5 is 25x squared and you subtract. So that gives you 37x squared minus 25x squared, which is 12x squared. Drop down the 11x, and then we start over. So what do I multiply 3x by to get 12x squared? Multiply it by 4x. So then we multiply and subtract. 5 times 4x is 20x, and subtract. 11x minus 20x is negative 9x. Drop down the negative 2. What do I multiply 3x by to get negative 9x? Negative 3. Multiply and subtract. Now this time when I multiply I end up with negative 9x, but I'm subtracting, which changes the sign and makes it plus. 5 times negative 3 is negative 15, but I'm subtracting, so that makes it plus. Negative 2 plus 15 is 13. That's our remainder, so we put plus 13 over 3x plus 5, and that's our answer to that. Solve the rational equation. So the key here is we're trying to get rid of the fractions because that makes it easier. And to do that, we take our denominators, and that's what we're going to multiply by. So we have an a, a 4, and an a, which means I need to multiply by 4a. So if I do that, I'm going to write it out. I'm distributing. And we want to see what cancels. So this a and this a cancel, this 4 and this 4 cancel, this a and this a cancel. So this 4 needs to be distributed. So that's 20 minus 4a. A times 3 is 3a. And 4 times 7 is 28. So subtract 20 over, add like terms. So negative 4a plus 3a is negative a. 28 minus 20 is 8. Negative a equals 8, which means positive a equals negative 8.
This one is kind of the opposite. This one says rewrite the expression with a rational exponent. Since this is a square root, because there's not a number right here, then that means we would say this is 39 to the 1/2 power. Then that's all it wants us to do, so that's the answer. Number 5, simplify by factoring. So what we want to do is we want to say, how can I break up 12 into its factors using a prime number tree? Or I feel like there's another word for it, but anyway. So what multiplies together to get 12? You might think 2 or 6 or 3 or 4, 3 and 4, and either one of those will work to use. If I use 2 and 6, then I have to split up the 6 into 2 and 3. And so what I care about is only the end of the tree, the 2, and the 3. What I'm looking for is pairs of numbers, because it's a square root. Pairs of numbers tell me to write that number on the outside. Anything left over out of what I have underlined is going to go on the inside of my square root. So my answer to this question is 2 square roots of 3. If there had been more than one number for either the inside or the outside, then we would multiply those numbers back together. So like if we had ended up with 3 times 2 square root of 2. Well, that's going to be 6 square roots of 2, if we'd ended up with something like that. Alright, on number 6, we can kind of think of this the same way as the previous one. If I have x to the 9th, then I have x written 9 times. 5, 6, 7, 8, 9. Okay, the way square roots work is every time I have a pair of something, I need to pull it to the outside. So I have a pair of x's here, a pair of x's here, a pair of x's here, a pair of x's here. How many pairs do I have? 1, 2, 3, 4. So on the outside of my square root, I need an x to the 4th. Inside of my square root, I'm going to have what is left over, which is that x right there. So this would be x to the 4th square roots of x. Number 7 asks us to multiply and simplify. Do it in that order. Multiply and then simplify. So we want to do 18 times 3. Since they're both under the square root, we're allowed to do that. 18 times 3 gives us 54. If we want to simplify the square root of 54, then we need to make a factor tree. So we just said that 18 times 3 equals 54, so that means we can put this right here. 18 is, it can be 2 and 9. 9 is 3 and 3. So, and then 3 doesn't, this 3 right here doesn't split off into anything. So if we're looking at just the end of our tree, we're looking at these 4 numbers, and we're going to say, what are our pairs of numbers? Well, I have a pair of 3's right here, so that means I need a 3 on the outside. I have a 2 and a 3 left over, so those go on the inside. Since there's more than one thing on the inside, I multiply that together. 2 times 3 gives me 6, so this is 3 square roots of 6. Number 8, add or subtract is indicated. What matters when we add and subtract square roots is that we have the same square root here. So this is kind of like them saying 3x minus 8x. If we did that, we would get negative 5x. But instead of actually having x here, the whole time we've had the square root of 3. So we have 3 square roots of 3. We subtract 8 square roots of 3, which means that we end up with negative 5 square roots of 3. That would be our answer. Number 9, we need to multiply and simplify. So we're going to use that all magical, so useful thing called foiling. So FOIL means to do first. 4 times 3 is 12. Outer, 4 times 2 square roots of 3. I'm going to go ahead and write that out. So I'm going to go back and write this out so that if you look back at it and you're like, what did we do? We did 4 times 3. Okay. Inner is square root of 3 times 3. Put the number first when you do square roots, because then it won't look like you accidentally had 2 numbers under your square root. And last, well, now this one's tricky. We can't do that, what I just said. So, alright, so square root of 3 times 2 square roots of 3. Now let's figure out what each of these is. 4 times 3, that's easy, that's 12. Here we can multiply the numbers on the outside together, and we can get 8 square roots of 3. Here, there's nothing actually to multiply, we just need to write that as 3 square roots of 3. Here, what we've got is these square roots right here, which we can multiply together. If I have the square root of 3 times the square root of 3, it gives me the square root of 9, and the square root of 9 is 3. So we need to say, well, this and this is like saying times 3, so 2 times 3 gives us 6. Now we have some like terms to add together. We have 12 and 6, which add up to be 18, and then 8 square roots of 3 and 3 square roots of 3, which adds up to be 11 square roots of 3. So this is our answer. Solve the equation. So we have a square root of x plus 2 equals 7. First thing we want to do here is we want to square each side of the equation, because that's how we get rid of square roots. The opposite of a square root is to square. When we do that, it leaves us with x plus 2, is going to equal 7 squared, which is 49. You would subtract 2 from each side. It's going to give us x equals 47 as our answer. Number 11, write in terms of I. So if it was asking us if this is a real number or not, we would say that this is not a real number. It's not a real number, but it's actually an imaginary number because of the negative that's underneath the square root. Okay, so we said when we went over this that if I have a negative 1, it's the same thing as I. So what we're going to do is we're going to say, well, I can take the square root of 14 or 16, take the square root of 16 and get 4, but I still have that negative under the square root, and it's going to end up, because I took the 16 out, it's going to end up being a negative 1 inside there. Well, now I have the square root of negative 1, so I can replace that with an I. So my answer is 4i. So when you see that negative under your square root and it wants you to write in terms of I, move it out and make it an I. Perform the indicated operation. Write the result in the form a plus bi. So it says perform the indicated operation. Our indicated operation here is addition. When we add two imaginary numbers together like this, we are adding like terms. 8 and 5 go together and make 13. Then negative 6i and 8i add together and give us 2i. That's our answer. Find each product. Write the result in the form a plus bi. Product means multiply, and if you look at this, hopefully you see that it's multiplication. Sorry. Anyway, but we're going to distribute the 3i. So what we're saying is 3i times 7 minus 3i times 8i. Okay, and the minus in the middle is because of this minus in the middle. So 3i times 7, I'm going to do 3 times 7 and get 21i. And then here I'm going to do 3 times 8, which is 24. That minus sign in the middle stays there. Then I'm going to do I times I. That's just like saying x times x is x squared, so I times I is I squared. Now, I squared, though, has another meaning. I squared equals negative 1. And so when we're simplifying or writing an answer and we have an I squared, we move it out, well, we get rid of it, and instead we put a negative 1 there. So this is really 21i minus 24 times a negative 1. Two things we want to do to fix this. We want to write this in the form a plus bi, which means our number right here needs to go in front of what number, of the part of the number that has I. Also, keep in mind, we have a negative 24 times a negative 1, which gives us a positive 24. Then we want to write this, which is a positive 21i. So our answer is 24 plus 21i. Solve the equation by the square root property. If possible, simplify the radicals or rationalize denominators. Express imaginary solutions in the form a plus bi. Well, let's just go for it. We want to solve this for x, so we're going to start off by getting x squared by itself. It means I need to move the 4. To move that 4, I'm going to divide each side by 4. That gives me x squared equals 7. Now, to get rid of this squared, I need to do the opposite of squaring, which is square rooting both sides. So when I take the square root, or when you take the square root in an equation, we have to put a plus or minus sign in front of what we get, which in this case we get square root of 7. If you don't put that plus or minus there, then you get it wrong. Because if we go back and plug positive square root of 7 and negative square root of 7 into that original equation, we do end up getting 28 on the right side. So you have to have both. We take this number that's in front of x, we divide it by 2, always 2. We always divide it by 2, and then whatever number we get, we square. It gives us 49. So when we're completing the square, we're trying to figure out what am I going to put here so that this equals x plus or minus, depending on what it is, squared. And the number that goes inside of here is always this number that we got. So this would be plus 7. So what we're saying is, I want to be able to factor this into something times itself. So x plus 7 times x plus 7, if you FOIL that out, you get x squared plus 7x plus 7x plus 49. Hey look, we get x squared plus 14x plus 49. So that's what we were trying to do the whole time. And so it's really easy to do if you can remember this. You have to take this number in front of x, divide it by 2, so you get 7 here, then square it, get 49. That number goes here. Then we say that equals x plus 7 squared. Completing this square on 19. I'm trying to solve this quadratic equation. So what we want to do on this is kind of like what we did on the last problem. We're going to start off by moving this 11 over. So we get x squared minus 12x. We're going to leave a spot here. If we move the 11 over, that means we subtracted it over. Leave a spot there. We're trying to figure out what to put here so that we can factor into something squared. So to do that, we take this number and we say, alright, negative 12 divided by 2 is negative 6. Square that negative 6 and you get 36. So I need to put 36 right here. If I put it on one side of my equation, I need to put it on the other to keep my equation balanced. So once I have that, my next step on the left side is to factor this into something squared. Remember that this something that goes here comes from this number, so x minus 6 squared equals negative 11 plus 36, which is 25. And now this is an equation like it was on 16, 17, something like that, where we can square root both sides and get x minus 6 equals plus or minus. The square root of 25 is 5. So we add 6 to both sides. We get x equals positive 5 plus 6 and negative 5 plus 6. That's what this plus or minus means, is that what if we have positive 5 and negative 5 and we add 6 to both of them? We end up with two answers when we do it. So one answer is going to be 11. The other answer, negative 5 plus 6, gives us 1. So we'd say x equals 11 and 1. Use the quadratic formula to solve the equation. So let's write out the quadratic formula. Okay, there's the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The way we figure out what a, b, and c are to plug in is a is the number in front of x squared, so here a is going to equal 1. B is the number in front of x, which is 7. C is the number that's left over, which is 5. So we got to plug in x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Then we need to simplify. I'm going to leave the negative 7 alone, let it just hang out. Figure out what is underneath this square root. What is 7 squared minus 4 times 1 times 5? You can do that on your calculator if you want to, or you can do it in your head. That should be 49 minus 20, which is 29, over 2 times 1, which is 2. If this number was a number we could simplify underneath our square root, we would want to do that. But I can't factor 29, so this is actually, that was our answer, so we really don't even have to write it again. Negative 7 plus or minus the square root of 29 over 2. use the discriminant to determine the number and type of solutions for the given equation. The discriminant is b squared minus 4ac. If when you work that out, you get a positive number, if you get a positive number, you have two real solutions. If you get 0, then that's one real repeated solution. If you get a negative number, that's two imaginary solutions. Okay? So this is kind of like the quadratic formula, you just have quite a bit less work to do. So here A is 1, B is negative 7, C is negative 8. So b squared minus 4ac, this would be 49 plus 32, which is 81. That is a positive number. Okay, and so if it's a positive number, that means there's two real solutions. And last one for the discriminant. This would be a equals 1, b equals negative 3, c equals positive 3. So we do negative 3 squared minus 4 times 1 times 3. So that's 9 minus 12, which is negative 3. Since that's a negative number, that means I have two imaginary solutions. Alright, we want to, on 24 and 25, write a quadratic equation in standard form with the given solution set. So they're telling us these are the answers to some quadratic equation. We want to find that quadratic equation. So what we're going to do is put these in as factors. But we're going to put them in with the opposite sign. So this is x minus 2, x minus 8. We're going to FOIL this out, and then that's what our answer is going to be. So, good old FOIL. So, x times x is x squared. X times negative 8 is negative 8x. Negative 2 times x is negative 2x. Negative 2 times negative 8 is plus 16. So here in the middle, we want to add those together. X squared minus 10x plus 16. Alright, on 26 we want to sketch the graph of the quadratic function using a table of values. The quadratic function gives us a parabola. So what we want to do is we want to find our vertex first, which we use these two numbers for. Now that we've gone over conic sections, remember that this number is attached to our x, so that tells us our x value, but we take the opposite of negative 2 because it's inside the parentheses, so it's going to be positive 2. The number on the outside gives us our y, and we don't change our sign. You only change the sign when it's inside parentheses, like it is right here. This is not inside parentheses, so we don't change the sign. Then we make a table of values, and we put our vertex in the middle, and then we pick numbers that are close to the x value in our vertex. So I'm going to pick 1 and 0, 3 and 4. Then I'm going to plug those numbers in. So let me get rid of all this junk over here. Okay. So if we plug in 0, we would do parentheses 0 minus 2 squared minus 4. And you just type that right into your calculator. Calculator says, hey, that's 0. Then you plug in 1. You type that into your calculator goes, hey, that's negative 3. Then if we get those first two right, the next two should be a repeat of what we already got. But do them anyway to make sure we did the first ones right. That should be that does end up being negative 3. And this one does end up equaling 0. Now I need to graph this on our graph. So we need the point 0, 0, 1, negative 3, 2, negative 4, 3, negative 3, 4, 0. And then you connect your dots in a U-ish shape, U-like fashion. There's our parabola. Look how cute it is. Okay. 27. Solve the equation by factoring. So notice that this is x to the fourth and x squared and nothing. Normally we have x squared and x and a number. Okay, so that's going to make this get split up into x squared in our parentheses instead of just x's. But otherwise it works the same way as what we're used to. We need to say what multiplies together to get 100 that adds to get negative 29. So let's think about all the things that multiply to get 100. 1 times 100, 2 times 50, 3 doesn't, 4 times 25, and 5 times 10. So which of these sets of numbers, if I add them together, gives me 29? This one right here. But I don't want a positive 29, I want a negative 29. So we're going to say that's negative 4 minus 25, which is negative 29. So in my parentheses I put negative 4, negative 25. Now the trick to this next part, because we want to solve this, is we want to set each part of this equal to 0. And then we solve for x. So I would add 4 to both sides here, so that x squared equals 4. I'm going to take the square root of both sides. Remember that when you take the square root in an equation, you need to put a plus or minus. So this is plus or minus 2. On this other one, I add 25 to each side. I get x squared equals 25. Square root, x equals plus or minus 5. So I've got 4 answers here really, because I have negative 2, 2, negative 5, and 5. And this is to the 4th power, so we should get 4 answers like that. So that's nifty.
33. The thing that we want to remember for inequalities like this is anytime that you see a less than symbol, that's going to be an and problem. Anytime you see a greater than symbol, that's going to be an or problem. Well, what does that mean? And means shade between, or means shade out, away from your points. So on 33, you take each part of this and set it equal to 0. And you solve, so that gives us x equals negative 1 and x equals positive 3. And we put marks on our number line at those points, and it either needs to be an open circle or a parentheses, depending on how your teacher does it. Those both mean not equal to, because there's not a line underneath this, so we don't draw a filled-in circle, we draw an open circle or parentheses, not brackets. Then it says express the solution set in interval notation, which interval notation is where we write what are we shading between, which we're shading between negative 1 and 3, so that's what we put. As an inequality, you would put negative 1 is less than x is less than 3.
This next one looks a little different, but we're going to do the same kind of process. So x minus 1 equals 0 means we add 1 to both sides. We get x equals 1. X plus 6 equals 0. We subtract 6 from both sides and get x equals negative 6. So those are the two important places on our number line. And then, because this is a greater than symbol, up here we said that means it's an or, it means to shade out. Okay, and then we're going to write this with an inequality. We're going to say that If we look at this right here, this is saying that x has to be less than -6, or this part is saying that x has to be greater than 1. Number 30, this next one is easy. 2 to the 2.6 is what it's asking us to do, so on our calculator, we're going to do 2 and then the exponent button and then 2.6. When I put that into my calculator, it gives me 6.0628662666. This asks us to round our answer to 3 decimal places. So what you do is we're going to write all of this, and we're going to look at the next number and decide, should we round up or should we round down? Since it's an 8, we round up. So this is going to be 6.063. Graph the function by making a table of coordinates. So that means we need an x and a y. And when we graph parabolas, we find the vertex, and that's how we pick our numbers. For an exponential equation like this, we're just going to use -2, -1, 0, 1, and 2 every single time. So if I plug these numbers in, then on my calculator I'm going to do this. I'm going to do 4 housetop, or exponent button, whatever you want to call it, -2. Press enter, and it should give you 0.0625. And then you do 4 to the -1, you get 0.25. And then 4 to the 0, which gives you 1, 4 to the 1, which gives you 4, 4 to the second power, which gives us 16. Now, we're not going to actually be able to fit this one on our graph, so we won't use that, but we'll use the other points. At -2, we're just barely above 0. At -1, we're just barely above that. 0, we're at 1. 1, we're at 4. And then we go up from there. So here's our graph. Remember, our graph gets closer and closer to 0 as we go to the left. It never actually really touches 0. 32 and 33, we're going to use these formulas. We're going to use this formula for 32, this formula for 33. So they're telling us all this information in this problem. The P is for the amount that we are investing. It's our investment. The R is the interest rate. T is for how much time. And N is the tricky thing. N is whatever we get, however much. N comes from the compounded part. If we're compounding quarterly, that means N is 4, because we'd get our interest 4 times a year. So this $1,500 is P. This interest rate is R, but we change it to a decimal, so we move the decimal over twice. And then 2 years, that's going to be T. So we plug all this in, and I'm going to write it like what I would type in my calculator. 1,500, parentheses, 1 plus 0.1 divided by 4, close parentheses, exponent button, open new parentheses, 4 times 2. Make sure you put the parentheses around that exponent unless your calculator makes it all an exponent on its own. So I get 18,027.60. We round this to 2 decimal places since it's money, and that's how many decimal places money generally has. Now 33, we're going to use the other formula because it says that we are compounding continuously. So that doesn't give us an N to put in. We have to use the E button. So this is going to be A equals 6,000. E, which when you press E, it gives you an exponent. To get to the E button, you do second natural log, so second ln on your calculator. And then it should put in parentheses or it should open a parentheses, or it should give you an exponent or whatever. And then inside the parentheses we put the rate, which is 0.08, and we put the amount of time, which is 6 years. So it gives you 9696.45. 34, we want to find the composition. So this is saying that we want to do f of g of 3. And the way we work this out is we go backwards. We plug 3 into g, we find that answer, and then we plug it into f. So I'm going to take, and I'm going to do g of 3. So when I do that, I put a 3 where x is on the right side of my equation right here. So that's 3.4, which is 7. And then I want to plug that in to f. So f of 7 equals 7 squared plus 3 times 7. Because now I'm plugging into f. So that's going to be 49 plus 21, which is, I feel like 70. So that's my answer. So the main thing you have to watch out on a problem like that is that you actually know what you're plugging into first. First, you work backwards. First plug into G and then into F, not the other way around. On 36, do the same thing. F of G of X. So I'm going to take this, put it right here. So that means I'm doing 2x minus 3 over 2. Well, if I add like terms right here, I get 2x minus 6 over 2. So if these were really inverses of each other, that would have had to be a plus sign right here. And then the 3's would have canceled out, so we would have been able to cancel out the 2's. Because this does not equal x, these are not inverses, and we can stop. I'm going to find the inverse of the one-to-one function. So here's what we do. We pretend like this f of x is really a y, and then we switch the x and the y around. So this is going to be x equals negative 6y plus 8. Then we solve for y. So if I want to get y by itself, I would subtract 8 from both sides. Oops. So that's going to give me x minus 8 equals negative 6y. Then I divide by negative 6 on both sides, and I would actually leave it like that. X minus 8 over negative 6. Logarithms. So we're going to write the equation in its equivalent exponential form. We always start with the little number. That's the base of our exponential form. We go in a circle. That 3 becomes our exponent. We keep going in our circle. That 125 is what it equals. You can confirm that you did it right, because if you did, 5 cubed really should equal 125, and it does. Alright, number 39 says write the equation in its equivalent logarithmic form. So what we're going to do is start with the base number, which is 4. Write log with a base of 4. Then we go in a circle. So 1 over 16 should come next, and then it equals the exponent, which is negative 2. That's our answer. Use properties of logarithms to expand the logarithmic expression as much as possible. Where possible, evaluate logarithmic expressions without using a calculator. So expand, this is multiplication here, so that means that it changes to addition. We can split this up so that we have log base 3 of 2 plus log base 3 of 11. That multiplication switches to addition. Alright, 43, this says ln, which stands for natural log, so that's no big deal. It's got the same properties really as logarithms. We've got division here, So we're going to split this up into subtraction. The natural log of e cubed minus the natural log of 2. Now, ln and e go together. Like anytime they're together, we can cancel them out. So that leaves us with 3 minus the natural log of 2. Now we're going to go the other way, use properties of logarithms to condense the logarithmic expression. So here we have subtraction. We're going to change it to division. So log the base of 2 of 48 divided by 3. Since both of those are numbers, we can figure out what 48 divided by 3 is. It would be 16. Now, if it's possible, we're supposed to evaluate this logarithmic expression, and it is possible in this case because 16 is the same thing as 2 to the 4th power. If we change it to 2 to the 4th power, then look, these numbers match up in this logarithm, which means we can cancel them out, and our answer is really just 4. 47. This plus sign changes to multiplication. So before that, though, we need to move these numbers in front and make them exponents. So this is really log base b of y to the 9th plus log base b z to the 6th. Now we can feel free to change it to multiplication. So it will be log with the base of b, y to the 9th, z to the 6th, and then you might see that put in parentheses too, so that we know that all of that's inside of our logarithm. Okay, this is a good one. Use common logarithms or natural logarithms and a calculator to evaluate to 4 decimals. So what we do is log of 21 divided by log of 5. We always do log of the second number over log of the first number. We type that into our calculator. And we get, if we round to 4 decimal places, 1.8917, because the next number makes us round up. So there's our answer there. Solve the equation by expressing each side as a power of the same base and then equating exponents. Wow, it's like they told us exactly what to do. So I'm going to leave this as 2 to the 3x minus 7. I'm going to change this 4 because hopefully we all know that 4 is 2 squared. Now that these numbers here are the same, we can set the exponents equal to each other and solve to find x. So to do that, we would add 7 to both sides, divide by 3, and we get x equals 3. You have to start off though by changing one or both of those so that they have the same base. Solve the exponential equation by taking the logarithm on both sides. Use a calculator to obtain a decimal approximation. Correct 4 decimal places for the solution. So it wants us to take the logarithm on both sides, but since this is an e, let's take the natural logarithm of both sides. So we put a natural logarithm in front of what we have on each side. This cancels out because ln and e go together. So this is 4x equals the natural log of 8. So all we have left to do is divide by 4, and we'll get what x is. When you type this into the calculator, you need to put ln, and then it opens parentheses, and you put 8. Close that parentheses, and then do divided by 4. Or press enter between them, and that'll do the same thing. X equals 0.4 decimal places, 5199. Solve the logarithmic equation. We're going to do that by simply rearranging this as an exponential equation. So you start with your 2 as your base, rotate around here, your exponent is 5, it equals x, we just need to figure out, hey, what's 2 to the 5th power? It's 32, so x equals 32. And then 52, find the distance between the pair of points to give an exact answer. So we need the distance formula for that, which here is the distance formula. You subtract your x's, square them, you subtract your y's, and square them. So this, we're going to make x1, y1, x2, y2. So square root of 1 minus 4 squared plus negative 1 minus 3 squared. You can type this all into your calculator if you want to. So we would get, we actually end up, if you do this whole thing, we get 5. Because underneath here, you should get, this should be 9, should be 16, so you get 25. Square root of 25 is 5. Find the midpoint of the line segment with the given endpoints. The midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2, because what we end up with is a point, so we have like an x and a y answer instead of just one number as an answer. So if we plug in x1, y1, x2, y2, then we're going to get 7 plus 9 over 2, comma, 3 plus 7 over 2. If you do this in your calculator, do the top first and then divide by 2. Like do 7 plus 9, press enter, and then divide by 2. So that should give us 8, comma, 5. 54. Write the standard form of the equation of the circle with the given center and radius. What we do is we have this is h and k, and then this is r, and the standard form looks like this. So we just plug everything in. So we do x minus h, so x minus 4, plus y minus k. So that's y minus a negative, so that's really plus 5, equals r squared, which is 11 squared, which gives us 121. So the way this works, all of these formulas, circles, ellipses, hyperbolas, whatever, the signs change whenever we put them into the parentheses, or if we take them out of the parentheses, the signs change. Here's another circle. Now this time we've got parentheses here. So our center point is the opposite of negative 5 and the opposite of negative 4. So it's at positive 5, positive 4. Our radius is the square root of 9, which is 3. So we go to 5, comma 4, which is up here. And then we go 3 in each direction for our radius. And we connect the lines like so. 58, right? Find the standard form of the equation of the ellipse. So if we look, this is centered at 0, 0, so we're just going to have x squared over something plus y squared over something equals 1. Those somethings have to do with how far we're moving left and right, how far we're moving up and down. So left and right here, this is 7, so we square that and put that underneath our x. Right here we're going up and down 4, so we square that and put that underneath y. So our equation should be x squared over 49 plus y squared over 16. Sketch the ellipse for the equation. So we pull these numbers out of the parentheses and change their signs, and that gives us the center point. Negative 1, comma, positive 2. We square root the numbers on the bottom, and that gives us how far we're going to go left and right and up and down. So we go to the center, negative 1, 2, put a dot. We're going to go left and right 4, up and down 2. Here's our ellipse. use vertices and asymptotes to graph the hyperbola. So there's no parentheses here, so our center is at 0, 0. We square root these numbers just like we did with ellipses. It tells us how far to go left and right. So we go 7 left and right, up and down 2. And this time though we draw a box, because this is a hyperbola, not an ellipse. This box tells us where to draw our diagonal lines, which are our asymptotes. Then we know where to draw our graph based on what letter is first. X is first here, so we're going to draw on the left and the right side of our box. Another hyperbola, again at 0, 0. Square root. Now, what's underneath y is a 2, so we're going to go up and down 2. What's underneath x is 8, so we're going to go left and right 8. So don't let the whole y first make you draw your box wrong. We draw our asymptotes through our box. And then we say, okay, y was first, so we draw on the top of our box and the bottom of our box. 62, we want to write the standard form of the equation of the hyperbola. First thing we want to do is look at our graph itself, like the curved part of our graph is on the left and the right side of our box, which means that we have x squared first, y squared second. Okay, then we need to figure out what to put on the bottom of each of these. So we're going left and right 3. So we need to do 3 squared on the bottom of x, which is 9. We're going up and down 4, so 4 squared gives us 16 on the bottom of the y squared. Alright, we've got a parabola again. We want to use the vertex to, I don't need to worry about the intercepts, use the vertex and we're going to plug in some points, we're going to graph this. So notice that this is x equals, and so this is going to either be a parabola that opens left or right, not up or down like if it was y equals. So the vertex we get by taking this right here, which is attached to our y. Since it's in parentheses, we have to change the sign. So this is a positive 7 in our vertex. And then we take this number on the outside, that's our x, and since it's not in parentheses, we leave it alone. Our vertex is at 5, 7. So we stick that in the middle of our table of values, and then we pick values that are close to the y value we have, because that's where we're going to plug in, is on this side where the y is. So close to 7 is 5, 6, 8, and 9. And then we'll be doing like 5 minus 7 squared plus 5 in our calculator to figure out what should go like right here. So that should be 9. Then if we plug in 6, we should get 6. If we plug in 8, we'll get 6 again, and then if we plug in 9, we should get 9 again. Then we just have to plot our points. 9, 5, 6, 6, 5, 7, 6, 8, and 9, 9. So here is our parabola. Oops. Alright, we've got like 4 problems here that ask us to indicate whether the equation is a parabola, a circle, an ellipse, or a hyperbola. So 64 we know is a parabola because it only has one squared term. So it has to be a parabola. Then we look at these other three, and they all have both of the terms squared. So let's just go through, and we want to get the x squared and the y squared on the same side. So here I'm going to move this over to this side, and so that's going to give me 9x squared plus y squared equals 36. If it's a plus in the middle and these numbers are different that are in front of x squared and y squared, which they are, then this is an ellipse. And last, we subtract the y squared over here, so that gives us 25x squared minus y squared equals 225. This minus in the middle means that this is a hyperbola. Find the zeros for the polynomial function and give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. So each of these things that has an x here, we want to set equal to 0 and solve. That's going to give us our zeros. So here I'd subtract 4, get negative 4. Now we look at the exponent here, which in this case, since there's not one, would be 1. This has a multiplicity of 1. An odd multiplicity means it crosses. On this one, add 1 to both sides, so x equals 1. Our exponent here is 4, so it's a multiplicity of 4. An even multiplicity means our graph touches at that point. We want to use the leading coefficient test here, so we look at the very first term. We look at this right here and we say, if that's even and it's a negative, then that means it falls left, rises right. No, just kidding. That's not what I meant to say. Falls left, falls right. I would copy down that chart onto your cheat sheet if I were you. From, this was chapter 11, it should be in 11.1, so that you have it with you to be able to do this on the test. This is odd and it's positive, so that means it falls left, rises right. Determine whether the given function is even, odd, or neither. So we look at the exponents and we literally say, are these exponents even, odd, or a combination? Both of these numbers are even, so this is even. Both of these are odd, so this is odd. Graph the polynomial function. So to do this, we need to factor by grouping. So we're going to look at this part and see what we can factor out. So from the first part, I can factor out an x squared, which gives me x plus 3 left over. The second part, we can factor out a negative 1, so that will change both of those to positive. And then we want to continue factoring by saying, okay, the x plus 3 goes in front from both of those parentheses, and we're left with x squared minus 1, which is what was outside of our parentheses. Now I can factor this again, because this right here is x plus 1, x minus 1. Okay, so now I know that I have 3 zeros here. Okay, I have one where if I set x plus 3 equal to 0, I get x equals negative 3. If I set x plus 1 equal to 0, I get x equals negative 1. If I set x minus 1 equal to 0, get x equals positive 1. So I can draw that on my graph. I know that I'm going to go through negative 1, 1, and negative 3. I also know that since all those parentheses have exponents of 1 or no exponents at all, that it's going to cross at all those points. So we can look at the leading coefficient and say, hey, this is going to fall to the left and rise to the right. And then in between, we have to go up and down, something like this. So that's about what our graph should look like. Graph the function. So to start off by factoring this, so what do these have in common? An x squared. If we factor out the x squared, we're left with x squared minus 4. we can factor the x squared minus 4 into x minus 2 and x plus 2. So that means that there is a 0 at x equals 0, at x equals 2, and at x equals negative 2. So, and it also means because of the squared that at this 0 it touches the x-axis but doesn't go through. So negative 2, 0, 2. Leading coefficient test says that this is going to rise to the left and rise to the right. In between here we know it goes down, it comes up and touches, goes down and comes up and touches. So something like that. Use the factor theorem to solve the equation. What matters here is they said that 2 is a 0 of this equation, so we're going to do synthetic division to figure out what the other ones are. So we drop the 1, multiply 2 times 1 and get 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 5 plus 8 is 3. 2 times 3 is 6. We get 0, and if we don't get 0 there, we're in trouble. So what we're saying is x squared plus 4x plus 3 equals 0. So we factor that into 2 parentheses. So what multiplies to get 3, that adds to get 4. I believe that would be 3 and 1. So we set each part of this equal to 0, and we solve. So x equals negative 1, x equals negative 3, and also x equals 2, which is the 0 they gave us, are all zeros of this polynomial equation. Here we want to use the rational zero theorem to list all the possible rational zeros. What you do is you take the last number, you take the factors of it and put it over the factors of the first number. The factors of 8 are 1, 2, 4, and 8. The factors of the first number are 1 and 2, so each number on top goes with each number on bottom. So we get plus or minus 1, plus or minus 1/2, plus or minus, because on this I was using this with each of these. 1 over 1 is 1, 1 over 2 is 1/2. Okay, so now we're done with that one. Now look at it 2. 2 over 1 is going to give us 2. 2 over 2 is going to give us 1 again, which we already have. So then 4 over 1 gives us 4. 4 over 2 gives us 2. 8 over 1 gives us 8. 8 over 2 gives us 4. So these are all of the possible rational zeros. Okay, this one's kind of a long one. We want to find all the rational zeros of the polynomial function. The way we're going to do that is to list all the possible rational zeros, use synthetic division to find one of the zeros, and then factor to find the other two. So if we're looking at 18 over 1, since it's over 1, we can just start listing our possible zeros because it's the factors of 18. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. The likelihood that one of those really big numbers like 9 or 18 is the right one is pretty slim, so let's try 1. And what we want to have happen is we want to get a 0 at the end of our synthetic division. So drop the 1. 1 times 1 is 1, 2 plus 1 is 3, 1 times 3 is 3, negative 9 plus 3 is negative 6, 1 times negative 6 is negative 6, so no, wasn't positive 1. So I'm going to go out with a hunch. I think 3 might be a good one. So drop the 1. 3 times 1 is 3, 2 plus 3 is 5, 3 times 5 is 15, negative 9 plus 15 is 6, 3 times 6 is 18, voila! So this is saying we have x squared plus 5x plus 6 equals 0. Now this is kind of tricky to factor. What multiplies to get 6, that adds to get 5? Well, we have 1 and 6. we have 2 and 3. Those multiply to get 6. Which of these two add to get 5, 2, and 3? We can't use -1 and +6 because those multiply together to get -6. And we have a +6. So we'd put +2 and +3. And so then we just need to figure out what our zeros are. We'd set each of these equal to 0 and solve. So that means x equals -2, x equals -3, and from our synthetic division, x equaled +3. So there's our 3 zeros. Find the vertical asymptotes, if any, of the graph of the rational function. Vertical asymptotes we get by setting the bottom of our fraction equal to 0. X plus 3 equals 0, we'd subtract 3 from both sides, and x equals -3. That's our vertical asymptote for that one. On 80, horizontal asymptotes, there's 3 cases. Okay, this first case here, on all of these we want to look at the exponent of the first term on the top and the bottom. So if the top is less than the bottom, like it is on this one, because we're looking at the exponents, 1 is less than 2, then that means that our horizontal asymptote is at y equals 0. If on this next one the top equals the bottom, because in this case both of these exponents are 2, what we do is we take the numbers from in front, make a nice little fraction out of them. Y equals 15/5, which means y equals 3 is our horizontal asymptote. The last case we have is that the top is greater than the bottom, and that means that there is no horizontal asymptote. So this 3 and this 2, the top is bigger than the bottom, so there's no horizontal asymptote. Graph the rational function. So here's what we want to do. We want to figure out the vertical asymptotes by setting the bottom equal to 0. So that means that x equals +1 is our vertical asymptote. We want to figure out our horizontal asymptotes. If we look right here, these have the same exponent of 1, so that means y equals 2/1, which is just 2. It's our horizontal asymptote. And then from there we will graph this on our calculator, which I'm not really prepared to do. So you type this into your calculator. Make sure that whenever you type it in, you go to y equals, put the top in parentheses, divided by the bottom in parentheses. So just type that in real quick. And if you do, we should see that it goes this way and this way. Just like that. And here's another one, same process. We're going to set the bottom equal to 0 to find our vertical asymptotes. This time though, we can factor that into x plus 6, x minus 6, which means we have 2 vertical asymptotes, one at +6, one at -6. Then we look at this right here and say, okay, the top's exponent, which is 1, is less than the bottom's, so that means our horizontal asymptote is at y equals 0. So we have vertical asymptotes at 6, and, oh, that was -6, at -6 and at 6. We have a horizontal asymptote at 0, and so what it should look like is I think what it should look like is this. So maybe I was wrong. Maybe it goes the other way, because I think it goes... Yeah, the middle part's wrong. Sorry. Use your eraser. Middle part goes the other way. Goes like this. So again, put the top and the bottom in parentheses when you type it in. I like this. Then press graph. Good to go.